Good morning to you people, the Science Crew here. I am Luis Carlos and I'll be your host for today's topic, which is the Schrödinger's cat. Very important and famous experiment for quantum physics, designed and proposed by Mr. Erwin Schrödinger, a Austro-Hungarian physicist specialized in thermodynamics and quantum physics, very good friend of Einstein's, won a Nobel Prize and all that stuff that famous physicists did. But what's the Schrödinger's cat? How does the experiment work? Well, let's imagine a cat, and then we put this cat inside a box. But the cat is not alone. Inside the box with the cat we have a radioactive atom with 50% chance of going unstable, a Geiger counter, a flask with poisonous gas inside of it, and a hammer. Let's call our cat Whiskers. If the atom goes unstable, the Geiger counter will notice it, activating a mechanism that, in this case, will make the hammer break the flask with the poisonous gas, liberating the poison inside of it and therefore killing our lovely Whiskers. The other 50% of chances are that none of this happened and Whiskers is living and happily ever after inside his box with all his new toys. We just have one problem. Whiskers is inside a closed box, so we never really get to see whether he's alive or not. This, in quantum physics, is called a superposition state, which according to quantum mechanics means that Whiskers is actually alive and dead at the same time. He's neither alive nor dead. He's in a point between both, dead and alive at the same time, and we would have to open the box to discover whether he's alive or if he's not, and our curiosity and chances and poison killed the cat. If we analyze the experiment, we will see that the cat has two options: whether he lives and never watches the flask break, or he dies and watches the flask break. It cannot be the other way around. The cat cannot live and watch the flask break. So we can see that the reality of the cat is directly connected to the result of the experiment, which is determined by the position of a single electron. Why? Because if the atom goes unstable, it's because an electron was in a determined position, and that's why this equation exists, the Schrödinger's equation, which tries to determine the precise or the approximate location of an electron in a precise moment using its real energy and its potential energy, which in fact is trying to predict the result of the experiment, which is also the base for the multiverse theory, which says that there are infinite possible universes with infinite possible timelines. There might be a universe in which Whiskers lives, we might be in a universe in which Whiskers dies, there might be a universe in which we don't even exist. All the chances are possible in these parallel universes, and that's what the multiverse theory tells us, that our universe is not the only one. And if we look at it from the philosophical point of view, the cat has two options: whether he dies and watches the flask break, or he lives and never watches the flask break. We have two options as well. We might open the box and find Whiskers alive, or we might open the box and find Whiskers dead. Reality has to collapse in one point, and we are forcing reality while open the box to make it take a decision. But here's the real question: what is forcing reality to collapse when we see Whiskers alive or dead?